We're still working with exponents, and today we learned what happens when we are dealing with integer exponents, otherwise known as the negative exponents. So just to recap, if I have 10 raised to the 5th power, and I did 10 multiplied by itself 5 times, I would get 100,000. 10 to the 4th power equates to 10,000. 10 cubed equals 1,000. 10 squared is 100, and 10 to the 1st power is 10. We also learned last week that 10 to the 0 power is equivalent to 1. And the reason why this happens is if we notice, every time we are decreasing the exponent by 1 for base 10, in essence we are dividing by 10. And that holds true for the 0 power as well. 10 divided by 10 is equal to 1. Now what I showed you, when we come down to, all of a sudden we're coming down to the negative exponents. Okay? If I applied the same pattern and I took my 1 divided by 10, I would end up with 0.1 or 1/10. Okay, and let's apply the same pattern again. I am now going to take that and divide it by 10. I would get 0.01 or 1/100th. And I could continue this pattern going all the way down, keep dividing by 10, and I would realize I get 1/1000th, 1/10,000, 1/100,000. So we did this in class. And we were able to then take our rule and show it using my laws of exponents. I have 3 to the 4th divided by 3 to the 6th. I have the same base. Keep the base of 3 and subtract your exponents. So 3 to the 4 minus 6th power is equivalent to 3 to the negative 2nd power. Again, by using my math, if I expand everything out, my numerator is 3 to the 4th power, which is equal to 3 times 3 times 3 times 3. My denominator is 3 to the 6th power. It's 3 multiplied by itself 6 times. The only thing I did tell you is these cancel and simplify to 1. They just don't disappear. So in essence, I end up with, when I simplify this entire fraction, 1 over 3 times 3, which is 1 over 3 squared, okay? So what that is telling me is 3 to the negative 2nd power is equivalent to 1 over 3 squared. Like I said in class, anytime I have something raised to a negative exponent, just try to think of it like this. Put that over 1. It is in the wrong location. We never want to have a negative exponent. You're always going to then think of the reciprocal. In order to simplify it, it has to be positive. X to the negative n power is in the numerator. It is negative. It is not in the correct spot. It needs to belong as the reciprocal in the denominator. And then it would be x to the positive n power and 1 in my numerator. If I have 1 over x to the negative n power now in my denominator, again, like I said in class, we cannot have a negative exponent. You have to think about the reciprocal. He has to change his location. It is negative in the denominator, so we are going to put that base with a positive exponent in the numerator over 1. So let's try a couple of examples. Once we get the hang of this, it is not terrible. 4 to the negative 3rd power. Again, this is really equivalent to 4 to the negative 3rd power over 1. I like to put it over 1 for now. So 4 to the negative 3rd power is in my numerator, not the right location. I have a negative exponent. Let us now take the reciprocal and put that in the denominator, 4 to the 3rd power. So my final answer would be 1 over 4 cubed. Now, I have negative 5 to the 4th power. Remember, this is really equivalent to negative 5 to the 4th over 1. You have to be very mindful here. What is being raised to the 4th power? The 5. I'm allowed to have a negative. My exponent here is positive. So we are going to leave the negative alone, and it's negative 5 to the 4th power. That one does not change. Only when my exponent is negative do I have to take the reciprocal. Let's take a look at the next one. 7 to the 0 power is equivalent to 1. And now in this case, the entire base, negative 5, is raised to the negative 4th power. So again, I like to put it over 1 so I can think. What is the base? The base in this case is negative 5. Negative exponent. He's in the wrong location, so I have to take that entire base, which is negative 5, and now take the reciprocal. So the negative 5 goes in the denominator, raised to the 4th power. So my final answer here is 1 over negative 5 to the 4th power. When I have 2 to the negative 2nd power, x to the 0 power, y squared, let's take each one individually. So again, I like to put it over 1. 2 to the negative 2nd power right now is in the numerator. It is a negative exponent, not the right location. Let us now take the reciprocal. 2 squared belongs in the denominator. X to the 0 power, anything to the 0 power is equivalent to 1. Y squared is currently in the numerator. The exponent is positive. He's fine. Leave him alone. So leave him in the numerator. And that would be my final answer. You could write it as y squared over 2 squared. You don't necessarily have to show the 1. Let's take a look at my next example. 3x squared over y to the negative 4th power. Let's take each one individually. 3 really has an exponent of 1. That is positive. He's in the numerator. Leave him alone. He's fine where he is. X squared, again, I have a positive exponent. Leave the x squared in the numerator as well. Now let's take a look at that denominator. Y to the negative 4th. I have a negative exponent. Not the right location. You are going to now have to take the reciprocal. So y to the 4th goes in the numerator. So that would be my final answer. And you could write that just as 3x squared y to the 4th. You do not have to put it over 1. I'm just putting it over 1 right now to show you what is happening. So these get a little bit more confusing, so let's try the first one. 5 squared x to the negative 2nd, y to the negative 3rd power. Again, I'm going to put that entire quantity over 1. And now I'm going to take each one individually. 5 squared, the exponent is positive, so I am fine leaving him in the numerator. X to the negative 2nd power, I have a negative exponent. So I am going to take the reciprocal and make that exponent positive, so that goes in the denominator. Y to the negative 3rd power, he's in the numerator. Again, negative exponent. Let's take the reciprocal, put him in the denominator. So my final answer here is going to be 5 squared divided by x squared y cubed. Let's take one more. Now I am multiplying a monomial times a monomial. I don't have any powers to a power, so I can take each base separately. 3 to the negative 2nd power times 3 cubed. Keep the base, add your exponents. Negative 2 plus 3 is going to give me 3 to the 1st power. Let's take a look at the next one. X is really raised to the 1st power times x squared. Keep the base, add my exponents, I get x cubed. And let's take a look at the last variable, y. Keep the base, I am multiplying, add my exponents, negative 2 plus 5, and I get y cubed. So my final answer is 3x cubed y cubed. You could keep it as 3 to the 1st power, but please recognize 3 to the 1st is equivalent to 3. Now let's take a look at the last one. So I have many different variables going on, but it's still a monomial times a monomial. So nobody is raised a power to a power. I can just look at the bases, keep them, and add my exponents. Let's do the coefficients. 4 times 5 is equal to 20. A to the negative 2nd times a to the negative third. So I am going to add my exponents. Negative 2 plus a negative 3. I'm going to get a to the negative fifth power. Now let's take a look at b. b in the first monomial is to the first power. Keep the base. b to the first times b squared. Add my exponents. b to the 1 plus 2 is b cubed. Now let's take a look at c. c to the 0 times c to the fourth. 0 plus 4 is 4. Now taking a look at this answer, we're not in simplest form. I have a problem. I have an exponent that is negative. So I cannot leave it in this form. That is not in simplest form. So again, go step by step. The coefficient of 20 is fine in the numerator. Remember, this is really over 1. A to the negative fifth power, that's the problem. That is a negative exponent. Right now, he's in the numerator. So let's take the reciprocal and drop him into the denominator. b cubed is already positive. He is fine where he is. And c to the fourth is fine where he is. So my final answer for this problem is 20b cubed c to the fourth divided by a to the fifth. Please do me a favor, just take it one step at a time. If you need to show the work, I am absolutely fine, and I encourage you to show this type of work at the top, because a lot of times when you do it in your head, we rush, and we can make a wrong, mistake and add incorrectly. So I would prefer that you take the time and just write it out.